There's a powder sitting on the shelf of your local pool supply store right now that looks like something out of a Victorian laboratory. Deep purple, almost black crystals that dissolve in water and turn it vivid magenta. It was first synthesized in 1659. Municipal water treatment engineers have used it since 1913. It is the only substance on Earth that can chemically regenerate a green sand iron filter back to full capacity, meaning a filter that would otherwise cost hundreds of dollars to replace every few years keeps working indefinitely for the cost of a $6 bag of crystals applied a few times a year. Water treatment companies charge between $800 and $3,000 to install proprietary iron filtration systems with replacement media contracts. The replacement media costs $40 to $80 every few years. The filter industry generates $14 billion annually in replacement cartridge and media sales. And a $6 bag of potassium permanganate is the reason that number is higher than it needs to be for a lot of well water homeowners. Stick around, because I'm going to show you exactly what this compound is, why it has been used in municipal water plants for over 100 years, what it does to iron and manganese in well water that nothing else can replicate at this cost, and precisely how to use it to keep a greensand filter running indefinitely instead of replacing media on a recurring schedule. But first, think about what your well water is actually doing to your house. The reddish-brown stain around the toilet bowl that won't scrub off, the orange streaks down the side of the bathtub, the rust rings where glasses sit on the counter, the laundry that comes out of the wash with a faint yellowish tinge no matter how many times you run it, the hot water that smells faintly of rotten eggs, that is iron and hydrogen sulfide. Dissolved in your water, in invisible ionic form, they come out of the tap, perfectly clear. And then oxygen hits them, and they oxidize. And what was invisible becomes the rust-colored stain you cannot get off your fixtures. Iron levels above 0.3 parts per million cause staining. Manganese causes black or dark brown residue. Hydrogen sulfide is the rotten egg gas. All three of them are not health hazards at the levels typically found in residential well water. The EPA regulates them as secondary contaminants, meaning the concern is aesthetic rather than toxic. But they will stain, corrode, and ruin everything they contact over time, and no amount of scrubbing addresses the source. The solution that has existed since the early 20th century is a greensand filter combined with potassium permanganate. And the reason most well water homeowners have never heard this explained clearly is the same reason your mechanic has never mentioned high mileage oil on a seeping gasket. There is no recurring revenue model in a $6 bag. Here is what the chemistry actually is and why it works the way it does. Manganese greensand is a filter media made from glauconite, a naturally occurring green mineral formed in ancient marine sediments coated with manganese dioxide. That manganese dioxide coating is the active ingredient. When iron-bearing water flows through the filter bed, the manganese dioxide coating acts as a catalytic oxidizer. It converts dissolved ferrous iron, the invisible ionic form that passed through your tap, into ferric iron, the solid particle form that cannot pass through the filter bed. The particles are trapped. The water that comes out the other side is clear. The same process works on dissolved manganese and on hydrogen sulfide. But here's the critical thing that every filter salesperson glosses over. That manganese dioxide coating is a consumable. Every time it oxidizes iron or manganese from your water, it gives up a portion of its own oxidizing capacity in the process. Over time, weeks or months depending on your water's iron load, the coating becomes depleted. The filter stops working because the active coating has been used up, not because the physical filter is broken or worn out. The glauconite underneath is perfectly intact. The housing is fine. The plumbing is fine. The only thing that has changed is the chemical state of the coating on the media, and that coating can be restored completely with potassium permanganate. Potassium permanganate was first made in the 1600s and came into common medical and industrial use at least as early as the 1800s. Sir Alexander Houston introduced it into water treatment plants in London in 1913, and its use in regenerating manganese-treated greensand filters has been documented since that era. When a solution of potassium permanganate is introduced into a depleted greensand filter bed, the permanganate ion, an extraordinarily powerful oxidizer, reacts with the partially reduced manganese on the surface of the media and converts it back to manganese dioxide. The coating is restored to its original oxidizing capacity. The filter works like new. The process takes hours, not days, and requires no disassembly, no special equipment, and no professional. Regenerating greensand filters with a 1.5 to 2% potassium permanganate solution, done on a regular schedule, allows the system to operate smoothly with minimal maintenance year after year. The greensand media itself typically has a 4 to 8 year lifespan with proper regeneration, and the annual maintenance takes just 1 hour without special tools. This is not a workaround. This is the designed, intended maintenance protocol for greensand filtration. a protocol that has been documented in water treatment engineering literature for decades, that municipal plants use routinely, and that the residential water treatment industry has every financial incentive not to explain clearly to homeowners who might otherwise keep their existing media running instead of buying replacement cartridges. Here's exactly how to do the regeneration, because the method matters. First, potassium permanganate is a powerful oxidizer and must be handled with respect. Wear rubber gloves throughout. It will stain skin and clothing an intense purple that takes days to fade. Keep it away from children. Do not mix it with any other chemical. Store it sealed in a cool, dry location. Those are the safety rules, and they are straightforward. The compound is not acutely toxic at the concentrations used in water treatment, but direct contact with concentrated solution causes skin irritation, and the staining alone is reason enough to handle it carefully. The standard regeneration procedure is to prepare a 2 to 3% solution, 1 pound of potassium permanganate per 5 gallons of water, and apply it to the filter media until the bed is fully covered, then allow it to soak overnight. In practice, for a residential greensand filter, that means dissolving 2 to 4 ounces of potassium permanganate crystals in enough water to fill your filter tank, introducing the solution into the filter bed, and leaving it for a minimum of 4 hours. Overnight is better. The solution will be vivid magenta. That color is doing the work. The following morning, backwash the filter until no pink color remains in the wash water. When the backwash runs clear, the regeneration is complete and the filter is restored to full capacity. The water that passes through the filter during normal operation after regeneration is tested for permanganate residual by checking the color. Treated water should be completely colorless. A slight pink tint in treated water signals excess permanganate remaining in the system, which means another backwash cycle is needed before the filter returns to service. The colorless water means the regeneration was complete and no permanganate is passing through. For most residential systems, regeneration is needed every 1 to 3 months depending on your water's iron and manganese load. In homes with very high iron content, more frequent regeneration keeps the media from reaching exhaustion, which actually extends its life. Running greensand media all the way to exhaustion before regenerating shortens its lifespan compared to regular scheduled regeneration. Where do you find potassium permanganate? Pool supply stores carry it. It is the same compound used to treat well water and control algae in decorative ponds, and is sometimes labeled as a pond treatment or water clarifier. Hardware stores with a plumbing section often stock it. Online, it ships without restriction. A 1 pound bag costs $5 to $8 and is sufficient for multiple regeneration cycles depending on the size of your filter. When stored properly in a sealed container in cool, dry conditions, potassium permanganate has a shelf life in excess of 5 years. A bag bought today will still be fully potent. Years from now, 2 honest limits before you go, because this channel always gives you the complete picture. Potassium permanganate and greensand filtration address iron, manganese, and hydrogen sulfide. They do not remove dissolved chemicals, chlorine, heavy metals, pharmaceutical compounds, nitrates, or hardness. If your water has those issues alongside iron, you need a broader filtration approach that includes activated carbon or reverse osmosis downstream of the iron filter. Iron treatment and chemical filtration are separate problems requiring separate solutions, and pretending otherwise would cost you the clean water you're trying to get. Second, this video is specifically about maintaining an existing greensand filter. If you do not already have one installed, setting up a greensand system requires correct sizing for your flow rate and iron load, and getting that sizing right matters. Too small a bed and iron bleeds through. Too slow a backwash and the media clogs. The regeneration procedure described here is for maintaining a system that is already working. For new installation sizing, consult your water test results and a water treatment supplier before specifying the tank. This is the one step where getting a professional opinion on the numbers is worth it. In 1917, potassium permanganate cost more than $4 per pound, an extraordinary sum at the time. And water engineers still used it because nothing else did what it did to greensand media. Today it costs $6 to $9 and sits on the pool supply shelf next to the chlorine tablets. The compound has not changed. The chemistry has not changed. The filter media has not changed. What changed is that an entire industry grew up around selling you replacement parts for a system that was always designed to be regenerated with $6 worth of purple crystals. Now you know, and you won't forget it. Thanks for watching, and I'll see you in the next one.